Okay, welcome to a video on adding and subtracting rational expressions. Rational expressions, as you know from previous lessons, they look like fractions, but instead of integers in the numerator denominator, we have a rational expression in the numerator and denominators. As you know from fractions, so let's review some fraction work here. When I had 1/2 plus 2/3, we want to add these two fractions together. You can't do that because we do not have a common denominator. So what we did, we took the 1/2 and we multiplied that by a form of 1, and we take the 2/3 and also multiply that one by a form of 1. And the goal here is to create common denominators. Well, the least common multiple between 2 and 3 is going to be 6. So here I'm going to multiply both the numerator and denominator by 3, because when I multiply these, I got 1 times 3, that is 3, and 2 times 3, that is 6. And if we just check our work, 3/6 we know is the same as 1/2. Now over here I want to also create the same denominator of 6, so here we go and multiply with 2 over 2, so that makes 4/6. And now we have common denominators. We can add the numerators together and you get 7/6 as an improper fraction, or 1 and 1/6 as a mixed number. Now with rational expressions, that still works the same. Before we can add these together, you have to create common denominators. Now, if you look at this rational expression, luckily, both the denominators are the same. X squared plus 2x minus 3, and the same over here. So I can go ahead and just subtract these numerators. So we get 3x squared. I'm just going to copy down the first one here, plus 2x plus 10, and we're going to subtract, and then in parentheses, 2x squared minus 3x plus 4, that whole thing needs to be subtracted, and we're going to have now just the denominator of x squared plus 2x minus 3. Okay, so I'm subtracting them. I just didn't do the actual subtraction yet. Now, this whole thing needs to be subtracted, so what needs to happen with this negative in front of these parentheses? We need to apply the distributive property. Okay, so after applying the distributive property, then we can combine like terms. So we get, again, the first 3 terms are just the same. Now I'm going to apply the distributive property. So I get negative times 2x makes negative 2x squared there. The negative times negative 3x makes plus 3x. And the negative times the positive 4 makes negative 4. And it's all over the same denominator. Now, x squared plus 2x minus 3. Alright, now let's combine like terms here. Got 3x squared, I got a negative 2x squared, so that makes x squared. I got a 2x, a positive 3x, that makes 5x. And I've got a 10 and a negative 4, and that makes 6. All over x squared plus 2x minus 3. Now, so this here, we combine the numerators. Now, we don't know if this is the simplest form yet, because we need to factor numerator, denominator, and maybe there's going to be a factor that the two have in common. We can cancel that out and get a simpler version of this. Now, if I look at the numerator, we have a x squared plus 5x plus 6. There's no greatest common factor. It is not a special product. The 6 is not a square here. So let's try a simple diamond problem for that one. I'll try it way up here. Simple diamond problem gives me 6 and 5. So if we go ahead and multiply 6, we get 2 times 3. Add those together, you get 5. So that means that this one here I can factor as x plus 2, x plus 3. Okay, now I'm going to factor the denominator. Again, there's no greatest common factor. This is not a special product. This needs to be a square number if it's going to be anywhere close to be a special product. And I can do a simple diamond problem now. So I'll do the simple diamond problem up here again. So that is -3 and 2. So that is then the factors of 3 and -1. So that this then becomes x minus 1, x plus 3. And what do you know? There's two factors that they have in common. So these two we can cancel out because x plus 3 divided by x plus 3, that's just 1. And what we have left is x plus 2 over x minus 1. And this here is your final answer. So that is the way we started here. We already had common denominator, so right away we could start subtracting the numerator in the numerator. Then we factored and simplified it. Okay. Now another problem here is where we do not have a common denominator yet. And as you saw with the fraction work, if you don't have common denominators, you have to create common denominators. So the next problem that we're going to do is 4 over 2x plus 4, and we're going to add 8 over x squared minus 4. So let's go ahead and start working on these denominators. If I look here, this one here, I can factor out in the denominator a 2. So that gives me x plus 2. There we go. So we put this denominator in factored form. I'm going to do the same with the second fraction. I'm going to take the denominator, put it in a factored form. This is a special product, so there's x plus 2 times x minus 2, binomial squared. Now look at the denominators. They're not the same, so I cannot start adding. However, they are partially the same. They have x plus 2 here, x plus 2 there. So those factors are the same. However, what's different, here's a factor of 2. Here I do not have a factor of 2. So to make the common denominators now, I'm going to multiply by a 2 over 2 so that I get a factor of 2 in the denominator. So now they both are going to have a factor of 2. However, here's now a factor of x minus 2, and there's no factor of x minus 2 there. So I'm going to use a form of 1, x minus 2, x minus 2. And now, if you look, when I multiply this, both denominators will have the same factors. Now, what happens here, I need to multiply this as well. Well, this is going to be a distributive property here, so this gives me 4 times -2 and 4 times x. So when I simplify this numerator, I get 4x minus 8 all over, and then let's go ahead and put these factors here. So the factor of 2, factor of x plus 2, and a factor of x minus 2. Now don't start multiplying all this out, because in the end we want to see if maybe we can cancel out another factor. Over here we multiply the numerator by 2, so you get 16 over 2 times x plus 2, x minus 2. And now we have common denominators. Now we can add the numerators together. So you get 4x minus 8 plus 16, so 8 plus 16 makes 8. So we get 4x plus 8, and then all over the denominator of 2 times x plus 2, x minus 2. Now the denominator, we left it in factored form, which is good, okay, but the numerator is not in factored form yet. So we're going to factor out a 4, the greatest common factor of 4. You get 2 times x plus 2, x minus 2. Now you can cancel out the x plus 2 and the x plus 2 over in the denominator. These two cancel out, which then leaves the simplified form of 4 over 2 times x minus 2. And this is then the final answer in the simplified form for the subtraction that we started off with. So the steps that we went through, first off we factored both the numerator and the denominator. Then we wrote these ones on each side in order to get the exact same factors in the left side of the addition sign as on the right side of the addition sign. So we created common denominators. And I simplified this here by doing the distributive property. We added the numerators together, factored the numerator, we canceled out, and we have our final answer.